conversation on the sum of the measures of the interior angles of a polygon. In the last two videos, we did an example where we drew several polygon-sized shapes. We looked at the sum of their angle measures. Then we talked about a formula that you can get from looking at the table and seeing some sort of patterns that turn into, well, what if you have a 32-sized, polygon? What do you do with that sort of information? We've answered a lot of questions on those two pages, 327 and 326. Let's finish out page 327 by doing some more table work. Here we go. Bring it in with the information I have here. Number 11, I'm going to go with number 11. Complete the table. All right, so in the number of sides of a regular polygon, a little bit of that action here. I've got something to write with. I got my highlighter. We're continuing our second learning goal for this activity, which is exploring and finding a formula for the number of sides, the number of angle measures in an interior. Some of the angle measures for a triangle is 180. Some of the measures of the interior angles is 360, 540. I really am copying that table from over here into here. A hexagon has 720, a heptagon has 900, and an octagon has 108 degrees, totaling interior measures of their angles. So what's the measure of each angle? You take 180, divide by 3. You take 360 for a quadrilateral and divide by 4. You take 540 for a pentagon and divide by 5. It's the total, the sum total divided by the number of angles, or sides, but number of angles. 720 divided by 6, which I wrote 540. Why did I write 540? It's 108. My goodness. 720 divided by 6 is 120. 900 divided by 7. I don't know that one. I think it's a decimal. Hey Siri, what's 900 divided by 7?
900 divided by 7 is about 128.5714.
Okay. Hey Siri, what's 108 divided by 8?
108 divided by 8 is 13.5.
I wrote 1080. What am I doing here? I'm tripping all over the place. Hey Siri, it's 135. I don't even need to I can do that mental math calculation. So sorry, I needed to add an extra 0 on the octagon, and 1080 divided by 8 is 135. Let me confirm that. Hey Siri, what's no, stop. Hey Siri, what's 1080 divided by 8?
1080 divided by...
It's 135. Okay, so if a regular polygon has n sides, write a formula to calculate the angle measure of each interior angle. Well, we take our formula, right? We had our formula from way up above. This is the total of all of the angles. We're going to take this formula and we're going to divide by n, because n is the number of sides or corners or angles, right? So n minus 2 multiplied by 180. And we're going to divide by n. That will be the measure of one interior angle. The measure of angle, I'll say 1, just like that. All right, use the formula then to calculate the measure of each interior angle of a regular 100-sided polygon. I don't know, is that like a centagon? So 100 minus 2 times 180 divided by 100. That is our calculation. You put 100 where n is in the formula. Wherever there's an n for the number of sides, we're going to put 100 there, and then we're going to do the math. We're going to calculate. So 100 minus 2 makes 98 times 180 divided by 100. I'm realizing something here, a little math fact. This is 98%. 98 divided by 100 is 98%. So I can go to Siri and say, hey Siri, what's 98% of 180?
98% times 180 is 176.4.
Okay, there we go. 176.4 degrees. That is our sum calculation. If the measure of each interior angle of a polygon is equal to 150, determine the number of sides. This is a formula, by the way, and so therefore there's an equality statement. In question 14, we're going to take the 150 and we're going to actually replace the measure of the angle 1, because it's a single angle that equals 150, and we're going to work backwards to find the number of sides. So we're going to leave n not identified. We're going to solve for it. N minus 2 times 180 over n equals 150. Now, if you multiply both sides by n, that'll make n cancel on the left side because it's on the denominator, and when you multiply by it, you are canceling a numerator-denominator together. So we have n minus 2 times 180 equals 150n. Now distribute, so that's the next step. Let's do 180 times 2, 180, or negative 2, and 180 times n. I'm running out of room in this paper. I have 180n. That's the first distribution. Let's see if I can zoom in on this. And then I have minus 360. That's the second distribution. You multiply right there, and it equals 150n. This is now down to like maybe 2 steps, maybe 3 steps really, that we need to do to finish solving it. So I'm going to do 2 steps at the same time. The first step I'm going to do is I'm going to subtract 150n from both sides. That way, 150n minus 150n becomes 0, and it's essentially canceled. Here's my second step, though. And then, by the way, I go to the other side, so I'm not on my second step yet. 180n minus 150n. You take 180 things, you give away 150 of those things, you're left with 30n. Okay, now, that's step 1. Here's step 2. In the same moment, I'm going to also add 360. Now, I can do that because adding or subtracting doesn't matter the order. Let's just do all the adding and subtracting at the same time. This minus 360 would still be on the same side of the equation as the n. I want it to go away, so I'm going to add it to both sides. Technically, there's a plus 0 number over here. So it's 0 plus 360. In other words, 30n equals 360. Last step. Divide by 30. And when you do, we get n equals 12. We are dealing with a dodecagon. In a dodecagon, the sum of each angle, well, the sum of the total interior angles would be 10 minus 2 times 180. That is 1,500. No, 10. It'd be 10. It'd be 1,800. And then you divide by 12 to get 150. Well, a 12-sided polygon, a dodecagon, has 150 degrees for each angle. Here's your full calculation for 14. Sorry that it all fits in the tiny little margin on that page. That's page 327. Thank you so much for watching this video. We are going to begin talking in the next activity about the exterior angles of a polygon. Also, one of my favorites. I'll see you then. Thank you so much. Bye.